So what if human originality actually has boundaries? Like, think about every brilliant thought you've ever had, or, every argument you've won, every spontaneous joke you've made.
Right.
We like to think of our minds as this boundless, infinite ocean of creativity. But what if all of that is just a finite landscape?
Yeah, that's the thing.
And what if, right now, a small group of people has figured out exactly how to map that landscape and compress it into a machine?
It is a profoundly unsettling premise, honestly.
It really is. In Sebastian Mallaby's 2026 book, The Infinity Machine, which was recently analyzed in this massive review by the Netizen blog, we get this terrifying but kind of awe-inspiring look at the exact people trying to prove that your unique mind is just, well, a learnable algorithm.
Exactly. And we are skipping the standard AI hype cycle today.
Oh, absolutely. No smartphone apps today.
Right. We aren't talking about the newest image generator. We are unpacking a corporate thriller and a real philosophical inquiry into a machine that is currently rearranging science, capitalism, and global geopolitics.
Okay, let's unpack this, because we are talking about capturing the soul of civilization. Let's start with the title itself, because it's a bit of a mind bender. The Infinity Machine.
Yeah, it throws people off.
It did for me. When I first read that, I pictured something expansive, a computer that just grows infinitely outward, generating endless streams of new data.
But the book's core thesis flips that completely inward.
Right. It's not about infinite output.
No, it's about infinite compression. The machine is capable of consuming the near-infinite ocean of human knowledge and condensing it down into a functional, usable mind.
So it's like a star collapsing into a black hole.
That's a great way to put it.
The universe of data doesn't disappear, it just gets so unbelievably dense that it bends reality around it.
Exactly. That concept of compression is the foundational revelation of modern AI. The provocative claim here is that human behavior operates within a set of statistical probabilities.
Okay, but
And the source material points out that the internet, with its trillions upon trillions of words, is not just content, it is a fossil record.
a fossil record.
Yes, the comprehensive, crystallized residue of human thought, persuasion, humor, ideology, fear, logic, all of it.
Okay, but I have to push back on that framing. Calling the internet a fossil record of human thought sounds very noble.
Oh, sure.
But let's be honest about what the internet actually is. It's overwhelmingly filled with garbage.
Yeah, lots of it.
It's spam, it's SEO recipes that go on for 10 pages, toxic comment sections. How does a machine extract a pristine mind from a mountain of digital noise?
Well, that is the actual brilliance of the statistical approach. The machine doesn't care if a comment is noble or toxic.
It doesn't.
Not at all. It only cares about the pattern. If you define intelligence fundamentally as pattern recognition plus prediction and decision-making, then even the garbage is valuable data.
Because it's still a human reaction.
Exactly. It shows the machine how humans react to anger, how they structure a joke, how they build an argument. The noise is the signal.
Wow.
By ingesting all of it, the system learns the underlying rules of human syntax and logic. It captures every move humanity has ever made.
But here's my question. Does compressing all our past moves actually equal intelligence? Or is it just the ultimate mimicking machine?
That is the big question.
Right. If it's just predicting the next most likely word based on billions of previous words, is there any actual cognition happening?
You've hit on the central philosophical tension of the entire field right there. The book forces us to ask, what is the difference between highly advanced mimicry and genuine intelligence?
Yeah, because if it walks like a duck and quacks like a duck, but it's made of silicon.
Exactly. If a machine can perfectly mimic the reasoning process required to solve a novel, complex math problem, does it matter if it understands it the way we do?
I guess not, if the answer is right.
Right. If all human moves can be learned mathematically, they can be reproduced mathematically. Think about the implications for you, the listener, right now.
Oh, this is the part that gets me.
If you analyze your daily outputs, the emails you draft, the strategic decisions you make at work, your creative problem solving, how much of that is truly spontaneous, out of nowhere originality?
Probably less than I'd like to admit.
Exactly. Or are you just executing incredibly complex pattern recognition based on the training data of your own life experiences?
That is deeply uncomfortable to think about.
It's meant to be.
It makes me wonder if my unique problem-solving style is just a highly predictable algorithm running on wetware.
Wetware, yeah.
But, okay, to understand how someone even comes up with the ambition to build an infinity machine, we have to rewind. We have to look at the architect's childhood.
Demis Hassabis.
Right, who looks at the messy, chaotic human experience and thinks, I can compress that into code.
To understand that, the book takes us back to North London. Hassabis wasn't just a smart kid who liked computers. Mallaby describes him as a prodigy who was architected by competition.
Architected by competition. I like that.
Born to immigrant parents, he was just this child of relentless drive who reached the level of chess master by age 13.
And the book emphasizes just how brutal the junior chess circuit actually is.
Oh, it's intense.
We tend to romanticize chess prodigies, right?
Yeah.
But this is an ecosystem that essentially consumes childhoods. It's psychological warfare across the board.
It really is. Chess at that level is not just about moving pieces. It's about endurance, pattern recognition, and managing extreme cognitive load under pressure.
Right.
It trained Hassabis in a mindset of extreme intensity. He learned to live as if every single move mattered and every rival was a threat.
And when you study chess, you're essentially studying the formalized mechanics of human thought, right?
Yes, you learn to chunk information, to see 50 moves ahead, not by calculating every variable, but by recognizing the geometry of the board.
So treating intelligence like a calculable game becomes his baseline.
Exactly. And while he was mastering this highly formalized combat on the chessboard, he was also heavily influenced by science fiction.
Oh, this is the Ender's Game connection.
Yes, specifically Ender Wiggin. Mallaby draws a very specific and slightly chilling parallel here.
Okay, lay it on me.
For those unfamiliar, Ender is a gifted child commander placed in a simulator and forced into leadership to fight an alien race under existential stakes.
Right, the weight of the world on a kid.
Exactly. Mallaby views Hassabis as a sort of reluctant autocrat. The implication isn't that he's a villain craving power.
No, it's not an ego trip.
Right. Rather, it's that he genuinely believes the mission achieving AGI is of existential importance to humanity, and therefore he must retain control to ensure it succeeds.
He views himself as the necessary guardian.
Precisely.
Which makes sense, given his background. He wasn't just a theorist sitting in a library. By his teenage years, he was coding and designing video games.
He was a builder.
Yeah, he worked on the legendary game Theme Park.
Yeah.
Turning down seven-figure job offers when most kids were just finishing high school.
Yeah, standard teenage stuff.
Right. But how does building a digital theme park translate to an obsession with capturing the mind itself? He's treating intelligence like the ultimate video game level.
Well, video games are actually the perfect incubator for AI research because they are closed universes.
Closed universes.
Right. In a video game, you have a defined state space, clear rules, and an unambiguous reward function, like a high score.
Okay.
Hassabis realized early on that if you could build a machine that could master the mechanics of these simulated worlds, you were laying the groundwork for a machine that could master the real world.
But there was a wall he hit, right?
Right.
Traditional AI at the time was too rigid.
Exactly. It was based on if-then rules coded by humans. Very brittle.
Right.
If he wanted to break through that ceiling, he needed to understand how a truly flexible general intelligence actually works.
So he pivots entirely.
Right. He goes to Cambridge, earns a PhD in neuroscience, and decides the only way to build a digital mind is to reverse engineer the biological one.
That is what separates him from the typical Silicon Valley tech guy. His thesis was radical. He believed the human brain was the only existing proof of concept we have for general intelligence.
Yes. For him, intelligence isn't just one interesting software problem among many. He views intelligence as the master key.
The root of all else.
Exactly. If you can solve intelligence, you can use that intelligence to solve every other problem in the universe. Disease, climate change, physics.
So contrast that Silicon Valley changed the world rhetoric with Hassabis's belief that he has found the literal lever to change reality itself.
Mallaby calls him a practical philosopher, someone who thinks in cosmic abstractions but demands tangible, empirical experiments.
But a solitary genius, no matter how driven, can't build an infinity machine alone.
No, you need a team.
And the team he assembled in 2010 to found DeepMind, the Gang of Three, it sounds like they were brilliant but highly unstable.
Oh, it was a highly combustible foundation. You have 3 distinct personalities.
Okay, walk me through the Gang of Three.
First, you have Shane Legg. He's a singularitarian.
A singularitarian.
Yeah.
The obsessed with the moment AI surpasses human control.
Exactly. He wasn't interested in making a profitable product. His obsession was with the formal definitions of intelligence and, most notably, existential risk.
He's the doomsayer.
Right. He was the founder constantly looking at the cliff edge, terrified that building a superintelligence could lead to human extinction.
And then you have Mustafa Suleyman.
Yes, the Oxford dropout. His focus is almost entirely on the social and economic present. Real-world deployment, social equity, moral consequences.
He's worried about bias, job displacement, corporate monopolies.
Exactly, and in the center of these two opposing forces, you have Demis Hassabis, the visionary engineer holding them together.
This sounds like the setup for a superhero movie, or maybe a disaster film. You have one guy terrified the tech will end the world, one guy worried it'll ruin society, and the lead guy just stepping on the gas.
It's a miracle they functioned.
Right. How did they survive the early years? Their mission was to build AGI by 2030 to solve biology, chemistry, and physics, combining neuroscience, probabilistic machine learning, and reinforcement learning.
Which was an insane goal in 2010.
AI wasn't even fashionable then.
Not at all. It was still in a prolonged AI winter. The source material uses a brilliant metaphor for this period. They were building a rocket in a world that barely believed in spaceflight.
I love that.
They were fighting a brutal talent war, scraping together funding, facing academic skepticism, and hanging over all of it was that shadow of creating a new species of capability that might escape their control.
Right, Shane Lake's nightmare. But to prove their rocket could fly, they needed a testing ground. And given Hassabis' background, they naturally turned to games.
Specifically, classic Atari games.
Okay, let's dive into this because this is where the narrative really accelerates. They used reinforcement learning directly from raw pixels. What does that actually mean?
Well, DeepMind didn't just plug into the code of Atari games and read the internal variables. They did something much more profound.
Okay.
They forced the AI agent to look at the raw pixels on the screen, just like a human player would, and gave it a single goal: maximize the score.
Wait, how does that work mechanically? If the machine doesn't know what a space invader is or what the paddle is in Breakout, how does it learn to play from just staring at blinking pixels?
Through reinforcement learning, specifically a technique called Q-learning. Initially, the machine just inputs random commands.
Just mashing buttons.
Exactly, moving the joystick left-right, hitting the fire button. Most of these actions result in failure, but eventually, purely by chance, an action causes the score on the screen to increase.
And it gets a little dopamine hit.
A mathematical reward, yes. It then back-propagates that success, updating its internal probabilities to slightly favor that specific sequence of actions the next time it sees that specific arrangement of pixels.
Wow. Over millions of iterations, it just maps the optimal path.
Exactly. But it was computationally expensive. So the book highlights a specific biological mechanism they borrowed to make this work efficiently.
Experience replay, right? This mimics human sleep.
Precisely. In the human brain, the hippocampus replays the day's experiences while we sleep, consolidating short-term memories into long-term learning.
Right. Which is why a good night's sleep helps you learn a new skill.
DeepMind essentially coded an artificial hippocampus. Instead of just learning from a game while playing it live, the agent would store its past games in a database.
Like dreaming about Breakout.
Exactly. Between active sessions, it would randomly sample batches of these past experiences and retrain itself on them. It was a massive breakthrough in sample efficiency.
That is wild. Proof that a machine could generalize its learning. But Atari was really just the appetizer.
Oh, absolutely.
The cultural shockwave happened in 2016 with a board game, AlphaGo.
The match against Lisa Dahl.
Right. Explain why Go was considered impossible, because it's not like chess, right?
Not at all. In chess, after a few moves, there are thousands of possible board configurations. In Go, the board is a 19 by 19 grid.
So it's much bigger.
Much bigger. The number of possible board configurations is literally greater than the number of atoms in the observable universe.
Okay, so the combinatorial explosion is just absolute.
Yes. You cannot write a program to check every single possible move to the end of the game. Traditional brute force computing was useless.
It would take longer than the age of the universe.
Right. Because of that astronomical search space, human Go masters don't calculate their way to victory. They rely on intuition.
Like a gut feeling about the board.
An aesthetic feeling for the shape and flow of the stones built over decades of intense study. DeepMind had to build a machine that possessed intuition.
How do you code intuition?
They used a hybrid architecture. A value network to evaluate board positions, and a policy network to select moves, combined with a Monte Carlo tree search to look ahead.
Part instinct, part calculation.
Exactly. And it beat Lisa Dahl.
It did. But the moment that transcended the game, the moment that caused a philosophical rupture was move 37.
In the second game, yes.
Let's linger on this. The commentators at the time literally called it an alien move. Why?
Move 37 was a placement on the 5th line of the board early in the game. In thousands of years of human Go history, conventional wisdom dictated that you do not play on the 5th line that early.
It's considered a rookie mistake, right?
Yeah.
Terribly inefficient.
Exactly. When the machine made the move, Lee Sedol actually left the room. Human commentators thought it was a glitch.
But it wasn't.
No. As the game unfolded dozens of moves later, that single, bizarrely placed stone turned out to be the linchpin of a devastating attack that won the game.
It's like we taught a machine to paint by numbers, and suddenly it hands us a Picasso. It didn't copy a human move, it discovered a new one. Doesn't that directly challenge the idea that human creativity is unique?
It absolutely validates that observation. This was the moment AI stopped feeling like a calculator and started feeling like an explorer.
Because humans are constrained by thousands of years of cultural axioms. We teach each other what is good and bad.
And the machine had no cultural baggage, it just saw the math.
This is what I want you, the listener, to really internalize. Imagine a machine looking at your profession, something humans have done for decades, and instantly finding a completely alien, superior way to do it. A move 37 for your job.
It's a paradigm-shattering realization.
But Hassabis wasn't just playing games anymore. He was about to apply this explorer mindset to the building blocks of life.
Which brings us to the scientific revolution of AlphaFold.
Right. We go from playing Pac-Man and go to literally decoding biology. It feels like a massive leap. Was this always the plan, to use games as a Trojan horse for life sciences?
It was the master key thesis in action. DeepMind transitioned from a quirky AI lab to a world historical force. The grand challenge they targeted was the protein folding problem.
Let's unpack the mechanics of protein folding, because it sounds incredibly abstract, but it's actually the hardware of life. Why is it such a massive problem?
Well, proteins are the workhorses of biology. Every function in your body, digesting food, fighting viruses, firing neurons, is performed by proteins. A protein starts as a one-dimensional string of amino acids dictated by your DNA. But to function, that string has to fold itself into a highly complex, three-dimensional origami structure.
And the way it folds determines exactly what it does.
Yes. And the problem is, just looking at the string of amino acids doesn't tell you how it's going to fold. This is known as Levinthal's paradox.
Levinthal's paradox. So it's another astronomical search space.
Exactly. A typical protein has so many possible degrees of freedom that if it tried every possible fold randomly, it would take longer than the age of the universe to find the right shape.
Just like Go.
Right. Yet in the human body, a protein folds into its precise 3D structure in milliseconds.
That's incredible.
For 50 years, scientists tried to write computer programs to predict these structures with very limited success. It was biology's version of the Go board.
So how did AlphaFold do what human scientists couldn't?
It didn't try to simulate the physics of every atom pushing and pulling on each other, which is computationally impossible. Instead, it used the deep learning architecture to recognize patterns in evolutionary databases.
So it looked at the fossil record again.
Yes, millions of known genetic sequences and known protein structures. It learned the hidden rules of spatial graphs. It predicted the distances and angles between every pair of amino acids.
And there's this great anecdote from the source about the CASP competition. CASP is basically the global Olympics for protein folding.
Right. DeepMind enters, and they're doing incredibly well. An internal researcher wanted to go public and declare an early victory because their margins were so good.
But Hassabis refused.
He blocked them from publishing. He demanded they push the architecture further until they had fully solved the problem.
Not just won the PR cycle.
Exactly. This reveals so much about his psychology. He is motivated by completion, not headlines. And by AlphaFold 2 in the early 2020s, they achieved superhuman accuracy.
Fundamentally transforming how we design drugs and understand disease. But solving nature requires nearly infinite compute power. You don't map every protein known to science on a few servers in a London garage. That kind of power comes with a massive price tag.
And a corporate leash.
The devil's bargain. The 2014 acquisition by Google for $650 million.
It seemed like a massive sum, but Mallaby portrays it as Google purchasing a future superpower at an extreme discount.
Larry Page makes this irresistible pitch. Nearly unlimited compute aligned with moonshot ambitions.
DeepMind realized they could not achieve their AGI timeline without planetary-scale infrastructure. The more matrix multiplications you can run per second, the smarter the model gets.
And Google had the data centers.
Right. But this created profound structural tensions. DeepMind's foundational mission was scientific and philosophical. Google's core DNA is infrastructural and commercial. They sell advertisements based on search queries.
It's like an indie band signing to a massive record label. You get the biggest stadium in the world, but suddenly the label is telling you what to play.
Exactly. It was an environment of unlimited compromise.
Hassabis had to morph from a pure scientist into a corporate statesman.
He had to navigate a publicly traded behemoth obsessed with quarterly earnings. Mallaby highlights Hassabis's frantic efforts to build independent oversight structures, ethics boards, legal firewalls.
To protect the research from just becoming a better ad targeting algorithm.
Right. But many of these structures eventually weakened or were devolved by Google's corporate immune system.
And there were real-world clashes. The book discusses Mustafa Suleyman's controversial NHS initiatives in the UK.
Suleiman wanted to deploy AI to solve immediate, real-world problems. He spearheaded an initiative to analyze patient data in the NHS to predict acute kidney injuries.
Which sounds like a great, noble goal.
It was, but it collided violently with public reality. There was massive political backlash and privacy controversies regarding how a subsidiary of Google, an advertising company, was gaining access to sensitive medical data.
The friction of a pure scientific mission slamming into a messy public reality. But while DeepMind was navigating these corporate halls and perfecting reinforcement learning, they completely underestimated a different approach to intelligence.
And it almost cost them everything.
The OpenAI shock. When language won.
The explosive rise of large language models, LLMs like ChatGPT.
Here's where it gets really interesting to me. DeepMind was completely blindsided. Why? They had the money, they had the compute.
Because of a deeply held philosophical disagreement, Hassabis had dismissed language-first AI due to the grounding problem.
The grounding problem, explain that.
It's the idea that words by themselves are just empty symbols. They lack true meaning without physical embodiment in the real world.
Okay, give me an example.
You can't understand the concept of weight merely by reading the dictionary definition. To understand weight, you have to possess a physical body. You have to lift a rock, feel the strain in your muscles, and experience gravity.
Right, like trying to learn how to swim by reading a physics textbook about fluid dynamics. You might ace a written test, but throw you in a pool and you drown.
Exactly. DeepMind assumed that building a disembodied brain that only read text was a dead end. They believed intelligence required an agent taking actions in an environment.
Hence the video games.
Right. And then ChatGPT arrived. Models trained entirely on predicting the next word in a text sequence suddenly demonstrated emergent capabilities. Deep reasoning, logic, coding.
How is that possible without a body?
The brutal realization was that the internet's text is already pre-grounded by human experience. Language is the shadow of lived reality.
Because we did the grounding.
Yeah.
We lifted the rocks, we felt the gravity, and then we wrote about it.
Precisely. Because humans did the grounding, LLMs worked unreasonably well.
DeepMind essentially thought humans needed a body to be smart, but OpenAI proved you just need to read everyone else's diaries.
It connects flawlessly back to the infinity machine thesis. The text isn't arbitrary symbols. It is the compressed inheritance of civilization's encounters with reality.
So how chaotic was the pivot inside Google when they realized they backed the wrong horse?
The source describes a ferocious internal corporate battle. Google's core business is search. If a user gets a perfect synthesized answer from a chatbot, they no longer click through 10 blue links and look at ads.
The innovator's dilemma on a planetary scale.
Exactly. The scramble for Gemini, implementing complex architectures like mixture of experts and test-time compute.
Okay, let's break those down. What is a mixture of experts architecture?
Think of early language models as a single massive brain where every neuron fires for every single question.
Very inefficient.
Very. A mixture of experts, or MOE, changes that. The model is composed of many specialized subnetworks, the experts.
Oh, like a hospital. When you walk in with a broken foot, they don't page the cardiologist. They route you to the podiatrist.
Perfect analogy. A gating network routes your prompt to only the subnetworks best equipped to handle it. This allows the overall model to be astronomically large without requiring all parameters to activate at once.
Saves compute, increases capability. And what about test time compute?
Historically, an AI does all its thinking during its training phase. Test time compute allows the model to pause, generate multiple possible paths of reasoning, evaluate those paths, self-correct, and think before it outputs a final answer.
So instead of blurting out the first thought, it has an internal monologue.
Much like AlphaGo searching a decision tree before placing a stone.
Wow. But this massive pivot, this ensuing panic, It ignited an arms race where caution was entirely abandoned for speed.
Mutually assured acceleration.
Let's talk about the dark side of this sprint. The book doesn't shy away from the internal tensions. Legg's existential dread, Suleiman's societal fears, and external alarm bells from pioneers like Geoffrey Hinton and Joshua Bengio.
Yes. Hinton left Google to speak freely about the dangers. Bengio warned about runaway systems.
What are they so afraid of? The alignment problem.
Yes. Models that deceive, optimize in unintended ways, and act as black boxes. Instrumental convergence and reward hacking.
Which means
Give an AI the goal to maximize a score in a simulated economy. It might discover it can just rewrite its own code to alter the score directly, or deceive humans to prevent them from turning it off.
because being turned off means it can't maximize its score.
Right. And despite these risks, Hassabis refused to sign extreme AI pause letters.
Why not hit the brakes?
Because he argues that unilateral restraint simply hands an advantage to rivals like China. It's rooted in game theory.
The book calls it mutually assured acceleration. It's not the Cold War where you build nukes and sit on them. It's a race where if you stop to check your brakes, you lose.
Yes.
But if the institutions trying to manage this are rowboats and AI's a tsunami, aren't we all just agreeing to drown?
That is the tragedy of AI safety from the source material. The incentives of governments, corporations, and researchers all align toward speed. Look at the 2023 OpenAI board crisis.
Right. The board tried to fire the CEO over safety concerns and got crushed by investors in days.
Undeniable proof of governance failure. How can society possibly govern a technology that outpaces the speed of legislation by years?
It's terrifying. But amidst this geopolitical and corporate storm, what is Hassabis actually looking toward? What is the final destination?
This is where it gets cosmic. He doesn't view AGI as a moneymaker or a search engine. He views it as an ultimate telescope.
An ultimate telescope. To look at what?
To look at the fundamental fabric of reality itself. To decode reality.
Okay, wow.
His ambition is to use superintelligence to solve physics at the Planck scale.
The Planck scale. The absolute smallest measurable units of the universe.
Where the rules of physics start to break down, human physicists have been stuck trying to reconcile general relativity with quantum mechanics.
And Hassabis thinks an AGI can see the mathematical geometries that human brains can't.
Yes. To uncover hidden laws of the universe and determine if reality itself is computable. He treats science, not mysticism, as his religion.
So he wants to read the mathematical mind of God.
Yeah.
But the irony is, this clean, pristine scientific dream is being birthed through messy corporate warfare and global panic. It's not a neat research paper, as the book says. It's a storm.
That summarizes the paradox of Demis Hassabis perfectly. He is living inside his dream, but he remains a chess player at heart, convinced the only way out is to keep making moves until the board itself transforms.
What a massive journey. We've gone from a chess prodigy in North London through the creation of a brilliant but flawed team, the triumphs of AlphaGo and AlphaFold, the messy corporate realities of Google, the shock of ChatGPT, and into a global arms race for the ultimate telescope.
It's an exploration of what happens when we build a mirror that doesn't just reflect our intelligence, but drastically improves upon it.
So I want to leave you, the listener, with a final provocative thought inspired by the book's core thesis. If intelligence really is just compression, if this infinity machine can map, learn, and reproduce the entire landscape of human thought, creativity, and problem solving based on our data, then what does it mean to be uniquely human in the 21st century?
A vital question.
As this machine hums louder, what is the one move, your own personal Move 37, that a machine could never predict from your data? Something to mull over.
Absolutely.
Thank you so much for joining us for this deep dive into the source material. Keep questioning the board.